All right. Yeah, thanks, Peter. So this morning we are going to be talking about some more Globe data for the 30 years of Globe campaign. So first off, I'm Grace Crane Wright. I'm the field campaign coordinator here with the GIO STEPI team. And for those that don't know what that is the Globe Implementation Office, Science Training, Education, and Public Engagement team. And Peter is joining us from Oregon State University, and he's also the lead of the Globe Observer Land Cover um, uh, team and for the app and everything. And he's going to be talking a little bit more today about how this past 30 years of Globe data can connect us to our present observations. And he's going to show us some strategies and address some challenges that we might encounter when we're looking at our local data. So I'm really excited to have Peter with us today. Peter, the floor is yours.
Thank you, Grace. Like I said, I'm really excited to be standing virtually in front of one of the trees that I measured during our Globe annual meeting this summer. I love time data about time, things that help me understand the world around me. And that is what brought me to Globe over 12 years ago now, it seems like. Might even be a little bit longer. But I joined the Globe International Science Network at the time. And a lot of that was because I'm a scientist really interested in learning about what was going on in the pixels that we were mapping. And so, one of the great things about Globe is it has been going for longer than almost any other educational program, especially related to the science of mapping, measuring, and monitoring Earth. So when I was doing my research, I was looking for any sort of data that helped me to understand what I was seeing in the satellite record. And this is a common strategy. And so we opportunistically looked out for who collected any sort of information. And through that data collection, I ended up at the Globe database and all of the data that had been collected by this group up until that time. And it was really interesting because again, there's very few places that have a long time record of measurements in the same location. And we want to keep encouraging that because it is a very unique record and is the only way we can do climate research or long-term research. And when we think about all the things that we're studying, we really are concerned about how they're changing over lifetimes. So what I want you to start thinking about, and I'd like to take a moment here before I just start rambling on about how great data is and what people have done. Um, I want to take a moment here, and if we can get into the chat, I'd like to know how long have you been with Globe? How long have you been making measurements? And this is really important because the maximum number of time, the maximum year or number here is 30, right? Nobody can have been part of the program longer than 30 years. So what I'm really curious about here is this range of contributions from the group that is attending right now. So Grace, would you mind sort of keeping track of that a little bit here?
Of course.
All right. So uh, take a moment and let us know how long you've been here with Globe. All right, Grace, what are we seeing?
Right now, we're seeing about 3 years, but I know some folks on this call, and they've been part of Globe for a lot longer than that.
A lot longer than that. Exactly.
So I know that we have a good range here.
Good, exactly. And so, for those of us you who are watching the recording, take the moment as well and think about what brought you to this program. What were the key words? What was the thing that got you interested about this? And what I want to highlight is this is the part of science. You come to these things when you are ready, and hopefully somebody has created a system that allows you to play and contribute and be part of something that you maybe hoped was out there and maybe you just didn't know until this moment. So we want to, even though people have been maybe doing Globe for a long time or maybe for a very short time, it's never too late, and now is the time to get involved, because all of this data that I'm gonna we're gonna talk about really it gains more value every single day because you cannot go back and re-measure. Okay. And that is crucial, because that is one reason why we have a database, is so that we can collect this information in a way that retains and values the people that are putting your time in to make those measurements, right? But we all know that when a measurement can have all kinds of challenges. Maybe it's raining, maybe it's your first time doing it. Maybe the instrument that you're using is of a particular type, and maybe the technology doesn't exist anymore. So we can't, other people are making measurements in different ways. So this is one of our giant challenges of science, is just making sure everybody's measuring the same thing with the same tools. And if we're doing it over a long period of time, we really have to be thinking about the longevity of those tools. And this is the moment that we're in right now, where there's been a lot of technological changes that have happened over the 30 years of the Globe program. Um, for me, I'll get a little personal. I was just starting my college career at this time in 1995, and so we were just figuring out how to use the internet, how to connect people together. And so that again is one of these things that when we think about what has happened over 30 years, it is incredible that there were people who had a vision, were able to create these systems that again we get to play in today. And this is a really important piece, that what I'd like to do right here is ask you all, how long do you want to be involved with Globe? And it's okay if you don't want to be involved for the rest of your life. If you see, this moment, I need to learn something, or I'm curious about something, but we're curious too about this lifelong learning aspect. Because again, we're all busy, but that's where we can work together through systems like what the Globe program has put together, to allow all of us to put in the time and effort when we can, but also if we have other obligations, to be able to step away. And hopefully we have this large group, this large community that is able to keep going when maybe we need to change our focuses. Okay, so even though it can feel that, oh, we want everybody involved for 30 years or for your whole life, I want to recognize that life is long, it's complex, and these systems that we're talking about are ways of knowing and ways of sharing information. And so you'll hear a lot about databases, and that is our way of sharing information. And so one of the fun and exciting pieces is there are people who've just spent their whole career thinking about how to arrange data, and there's people who are just going to spend the next 30 years of their life thinking about how to arrange data. And I want to mention that when you do Globe Observer, you are creating somewhere around 70 to 100 pieces of information that has to be stored. It has to be maintained. It has to be made accessible. And so you might be thinking that I'm not doing a lot when I'm making a measurement. But we need all of these little pieces of information that you're providing to us. Okay. And all of that is really important for somebody to reconstruct or be able to research your information and your measurement. And that's the name of the game here, right? Is researching. And so let's talk a little bit about this. And I'm going to share my screen here once I get permission to be able to do that. And um, but I want to put into everybody's mind here this idea of generational science. Okay. And this to me is really crucial because That's how we know about climate. It's how we know about trees that actually might be living longer than an individual human life. Animals out there, who's there? Who has been there? Who's there now? All of these things are part of the conversation that we have with each other. And this is one of the things that I love about a photo. It can be the beginning of these conversations. And so we have a lot of research methods that really are just tell me about what you see in this photo or in this image or in this satellite picture or in a graph, right? Use that as a way of having a conversation with a parent or a community member or somebody else around you. Because as I want to really stress here, a picture is a measurement. It is reflected light. And we've gone into all kinds of details about what that might mean, how to work with that, that science behind the sun and our sensor of what we're measuring. But these are things that have really only become part of the globe world since 2018, maybe 2016. Many of us are just using mobile devices um, in the recent times. Okay, and so this is an example of that technological shift that has happened that has huge repercussions for comparisons to other globe measurements or other measurements, even outside of the globe database. Okay, and so so with that, um, I want to share my screen, and let's see. Let me find the right window there. All right, we're going to be sharing that one right there. And I want to, first share with you a good place that you hear me talk even more in depth about this idea of generational science. And so I'm going to share this with you because it's a 20-minute podcast that, again, highlights what I'm talking about, but in a different way. And this will allow you to hear the story. And what I want to encourage you to do is this is a great way of interviewing people, of finding out about what's in your area. Include things like this into your research. It's really, really useful to not only see things, but to hear the words, to hear how people describe things. Okay, so I just wanted to I love sharing this particular video or audio podcast with people, because it talks about how I got involved in this. And I kind of shared that slightly there at the moment. So I won't go into more details, but I encourage you to, you know, think about this long-term science that we're doing. And I want to stress this is public science for the good of the whole planet. And that is a reason why I am here is because these are public databases that are meant for education and science. And you can find all kinds of places to contribute and take observations and submit them. There's been a lot of other programs that have learned from Globe and have their own databases. That's great. We can actually use that to complement our measurements. And that, again, is one of these things that in 1995 to the year 2000, many people in Globe were all alone. They were the ones that were the only ones doing this. Now we have a lot of projects, a lot of lessons, and a lot of complementary data that's out there. Okay. So Globe is one source of data. It's a really good one, but recognize your job as a scientist is to not just use one source of data. It is to find as much as you can in your community to describe your location. And if it's not in the Globe database, that's great. Just describe that. And then one of the things that we want is to find out who has complementary data and find out how we actually bring that together so that we can work together as a team and understand the systems that are around us. Okay. And that's one of my big jobs as a scientist is just keeping track of who's measuring what and where are they storing it. Okay. So when you see articles out there describing methods, they should be telling you where you find your data or where you can find their data so you can research what they're doing. Okay. So these are all, again, strategies that I'm using on a daily basis to keep track of the keywords of what I am studying and finding out who else is doing something that will help me with my work. Okay. And I want to, I spend a lot of time recently um, taking photos of my environment. And sometimes they're the Globe Observer cloud photos. Sometimes they're Globe Observer land cover photos. Sometimes they're estimates of tree height. But this fact now that we actually have a remote sensing sensor in your pocket is data, like you just said right there, Grace. I love it. And this is again one of these transformations that I have this website up from the US Geological Survey because this is an example of a complementary data set that's out there. And it is also one that I worked with, at the beginning of Globe to look at how we use digital images to look at satellite data, also digital images. So this was before we brought this into the Globe program, we actually did research around, importantly, not just how to take a photo, but how to put it in, as we say, geospatial location. Okay. And that key word, geospatial, is really what makes Globe unique and our data set unique. It's not just that we have a temperature measurement. Great, everybody has that. It's that we have a temperature measurement at a location that has been measured through some device. And so that takes us to, I think, one of the most important foundational parts of every Globe protocol. And this is how we find our location in the world. It started off using GPS, global positioning systems. And in 1995, the technology was not great for the public. And I want to stress that. And in fact, for about the next 10 years, from 1995 to the year 2005, there was actually error introduced into this measurement that was getting made. Okay. So when you read here about take a GPS receiver, that tool is exactly like this mobile device. But when we look at any data that was collected during that time frame, during the 1995 to 2005 time frame, recognize there was error intentionally put in, and we have to deal with that. We have to think about that. And so that was one of those technology pieces that was just kind of part of the world. We can go into why, all those fun things, but just recognize that that is in the background to that data, and nobody's going to tell you that that was happening. You might experience it when you start looking at it, and it's that data point might not be in the location you think it is. But this is the data archaeology that happens. And so I want you to recognize that your job as a scientist here is to not just use the data, but to think about, again, what went into making that measurement and what could actually cause it to be too high or too low or skewed in a direction like that that takes it away from the real meaning. Okay. And so I want to stress this GPS protocol goes with every single measurement you make about the environment. We need to know where you are making this. And the important thing about the GPS protocol is that it's not just a single number, right? We have a latitude, a place, going from the equator, going north or going south. We also have a longitude going east and west. So your east-west photos go that way. What we've found in the past is the biggest error is people forget to include a minus sign. And so they end up literally in Russia when they were supposed to be in Alaska. Okay. So this is the most common error that you will come across when you're searching for data for your area, right? You're looking for data between some numbers. And if the data in the database was not input correctly or checked when it goes in, you will miss that data. Okay. So this is again one of these things that these numbers are really important, and I encourage everybody to get to know your numbers for your research area. For me, they're positive. They're positive numbers because I'm in the northern hemisphere, from 43 degrees north to 45 degrees north. That's what I have come to expect here. So when I am actually doing my globe observer, and using this device to put myself on the map, I know a little bit of what to expect there. Okay. And I found that this is going to be really useful when I go look on a map. The other thing is the longitude is one, our east-west direction is one that again in our database has been the most problematic. And so this ends up again putting something on the opposite side of the world if it is supposed to be east, and it has to it's supposed to be a negative sign, and it ends up being put in without that. Okay, so be aware of these numbers. The other one that is again really interesting is in 1995 we didn't have a global elevation map or value. Like that just didn't even exist. And so that was one of the early data sets that we needed to create. Okay, how high above sea level, or where is sea level? What is the height of Earth? And again, this elevation piece is foundational to land cover descriptions. It's really important for the cloud types that you might be experiencing. And so at the beginning of Globe, those two protocols were the focus. And so now we have many different ways of measuring elevation. And I want to highlight that this is a really fun one because elevation isn't static. And in fact, I would love somebody to go out and look at how has your elevation actually changed over the 30 years of Globe. And there are places that have actually uplifted, like Mount Everest has actually gone up in elevation over the last 30 years. We have sea level rise that you might have heard about that might be occurring. Well, what's our reference for elevation? You might actually have heard this term above sea level, ASL. Well, if sea level's going up, how does that affect our elevation measurements? So again, these three things might seem like they're very obvious. You do it once and you don't ever have to think about it. But what we found over the last 30 years is, in fact, these are dynamic numbers. The number of decimal points that you include with them indicates how accurate you are to a location in the world. And so and these are the places where we are finding errors in our database and we want to fix. Okay, so that's one of the things that you can actually do when, for a project is go through the Globe database and look for, measurements that might have been made by your class or your team or in your area and see, are they actually near the right location? Do these numbers make sense? Okay. And again, it kind of goes into this whole idea of what is time. One of these things that is important to think about is there's several different ways that we can in the Globe program reference time. One is through what we've been doing and what we do with our mobile devices. I'll put this up again. And what we did with GPS, we referenced ourselves to a location, 0 UTC, right? And that's essentially the same place that the longitude starts. So they're kind of related there. But this is the Greenwich time zone or Greenwich line. And again, this whole idea of time, we've gotten a lot better at measuring this. So what that is one of the things with our lasers in space now. The new GPS satellites that are up there. People who are focused literally on atom time, atomic time, have actually improved our accuracy and precision of this number over the last 30 years. Now, down to the second, it may not matter for what you're doing, but just recognize that referencing ourselves in time is actually what you're doing with GPS. That is a time measurement that you're making. So, again, GPS is a really fascinating, piece of things because it goes back to how do we first just locate ourselves in the world so that we can use the map technology and importantly, all of the other data that NASA produces that is placed on the Earth. Okay. And it's that placement on Earth that really is where we end up getting into some of the challenges or misalignment, or we have to start thinking about what is the resolution of the data that was getting collected. And in relation to our data that was getting collected. And this latitude, longitude, again, is our secret way of really finding what we're after. So I'm spending a lot of time stressing this piece because this is the wandering part of our data sets. I'm not as much concerned about the temperature measurement of that stream as much as I am making sure that in the database, we're actually standing on the shore where we made that measurement. Um, and we will, there's ways of looking at those individual measurements by themselves. But for me, and NASA data and our satellite measurements, latitude, longitude, time are crucial to be able to be doing any sort of science after this. And I just want to emphasize this even further that in 5 years, student projects are really going to need to have this down to the 3 meter accuracy that we can get with our current mobile devices. Okay. So to be able to do the science that we want to do in the upcoming 5 years, to keep globe moving forward, we really need to be paying attention to this placement on Earth. Okay. And this is also where some places are just really, really challenging. And we know that now. There's a lot of research out there saying if you are under a forest or under a tree canopy, these numbers are going to be influenced. And they're not going to be as good as standing out in the middle of a field. Okay. So our land cover actually affects this measurement. And so, again, when you're out there putting yourself on Earth with the Globe Observer, recognize how important that placement really is. Zoom in on your map. Make sure that you really put it where it should be. And that, one of the things about this GPS protocol is it does tell you how to calculate error around your latitude, longitude. Look for that. I personally get very skeptical if somebody just shows me a latitude, longitude, and there's no error around it. Those numbers are a measurement. And you can keep going down all the way down to centimeters to millimeters. But for us in the Globe program, we do have minimum resolutions that we're talking about here. So when we go to our database, which we'll jump over to here shortly, because this is always a lot of fun looking at text, right? But there's numbers that we should expect. So let me ask, to open it up, what is the range of values that we would expect for latitude? Drop that into the chat if you wouldn't mind, or just speak up if you have that capability. All right. So you should be going for between -90 and 90. And again, the number of decimal points that go along with this is really important. Okay, longitude. What is our range of values that we would expect for longitude? That's right. -180 to 180. Okay. And so this is again really important to be thinking about what are the numbers, and I didn't even give you the units that those numbers were in, right? So that's another big place that we see confusion in our database is in those units. And elevation, again, is one that trips a lot of us up and does cause problems in our database. Are you doing it in feet or are you doing it in meters? And again, we should not expect anything over 10,000 meters. We don't have anything like that. So if you see that number, that's a good indication that the units might have been mixed up. And again, these are historical problems that you will find within the database itself. So, these pieces are just so foundational, because when we go to our our map and try to actually put this onto a map and see where in the world, where geographically have we made measurements, those things really, really matter. Okay. And I want to stress that here we are doing a comparison and are looking at our location in reference to this map. Okay. So when you're doing this, you're actually looking at the OpenStreetMap and assuming that they're telling you the right things. You are assuming that their map of the world is correct. Okay. And so this group is something that's new. It wasn't around when Globe first started. We had other data layers or other maps that we would use to reference ourselves. Now we're using OpenStreetMaps. Okay. And I just want to stress that because these country lines have changed over 30 years as well, right? We do not have actually the same geometry across all of our countries. So recognize that even though you see something like this and the name of the country might be something, the geometry behind it might have changed. And that is, again, if we really zoom in and start looking at where our data is located, not just at the global view, but if we really start zooming in, this is where it really starts to matter, right? And importantly, between countries or between locations, if I zoom in really far here, this is 50 meters on the ground, our scale in the bottom here. And at this resolution, we want to make sure that you are in the right place. And the reason, again, hopefully other people and OpenStreetMaps is one of those references that have a good method that we can trust them overall, with their location of features of places, right? So if you are making your measurement and your GPS ends up not giving you the right numbers, you can use maps like this to reference yourself. That was something that wasn't even possible really 10 years ago when I first was really starting with the Globe program. But I want to stress this thing that is unknown to us. When was this layer digitized? What was the source of it? Who did it? Right? So I really appreciate that OpenStreetMaps is out there, but one of the things that again has happened over time is we now have authoritative data layers. We have data layers that the United Nations puts out that actually gives us the geometry that they're using to make decisions. Uh, and so this geometry of the different features that you see on a map is one of those things that it has improved over time. And so we can actually use that again to sort of look back at our data that was collected. And so, one of the things about, I'm going to just zoom out right here and see, um, one of the things about like, Globe Observer is, and the photos with land cover. I'm going to focus on land cover here for my last little demonstration because land cover, it was the second protocol that came out for the Globe program. And it's because everything is land cover. If it's not clouds and atmosphere, it's within the land cover sphere. Okay. And what you measure, that water, the trees, everything else is land cover. It's a land cover object. And what one of the things that you'll see is that we now have photos, right, that are available to go with our data sets. Now, luckily, we've been doing this for 6 years now, so this interval doesn't quite work for us anymore. Um, but one of the things that I do appreciate is you can open up and look at all of the photos that were collected over the 30 years of the Globe program. And one of the things that you will see with that is digital image technology changed. So the type of pixels, the color, the resolution, some of those things are different in there. You'll also see that before the Globe Observer mobile app came around, there was only 1,200 photos in the database. So it was a challenge to do this part of the protocol, to make those measurements, to put that inside of there. That's the reason why Globe Observer land cover came around, was to help facilitate this particular data collection. Okay. And so, with that, you can go back and you can look at all of the photos that were there, but just recognize that because of the technology, the depth of that data set isn't very deep. It's not 30 years necessarily. Um, and so, so that is a really important thing, that these menus might give you the impression that you have data for 30 years or for all time, but recognize that you do still need to understand the history of when this protocol came in, what instruments that they were using, and what people actually did with this. Okay, and here I'm, this one location that I was focused on here in Guatemala. Again, I want you to focus on, look at like the dates that are available for these, right? Um, and look, you have a couple different pieces between land cover and sky conditions. And I want to emphasize here that we tend to do a lot of things in Globe by individually. Your cloud photos complement your land cover photos, and your land cover photos complement your cloud photos. These are actually pretty intertwined. And so here, I mean, one of the things that comes up from this person is actually when they are doing their cloud observation, they are recording ground measurements. Use those. So even though the way the database is structured and the way that Globe has taught protocols as individually, you might actually find information in another protocol that complements what you are actually researching and studying. And sometimes it is basically like, well, somebody made water measurements over there. Okay, well, that's where the water is, right? Like, it tells you where the water is because that's where the water measurements were being made. There's a requirement there for that presence of water. And then you have on the other side, where water measurements aren't being made. Well, that could be waterless. And so that could be where your grass is, where your shrubs are, where your trees are, all those other kinds of things. So again, expand your mind a little bit here about how these protocols really do work together and complement each other in this way. Um, and so so one of the things I'll just zoom back out because I really like starting here on the Globe Viz system to look at where my data might exist. And so this is a place where I start to notice challenges or maybe locational errors in the database. And apparently that's really what I'm focusing on today because this is, again, one of our biggest challenges. And so here, if I go down, interesting. Once we refresh this, I start to I look at something like this and wonder, did somebody actually go to this location? This seems like, way off. And could it actually look like what this person is suggesting? Well, I don't know. But one of the first things that I do is I look for outliers like this. And one of the things that when I'm reviewing my data, all this data, one, I look for who submitted it. Okay, what's the likelihood that somebody from Mexico went to the North Pole, went all the way up there? It could happen. Okay, so I'm not totally, but when I then see the photos that are there, my skepticism that this is just in the right place really goes up. And this is the nice thing about photos, that if they complement your data, is it gives us another way of just making sure that that measurement is in the right location. Okay. And so this is a way that I start looking at this and I start wondering, does this place have this sort of water, this sort of environment, this kind of thing, right? Well, again, I'm going to zoom in. Okay, well, one of the big errors and things that I'm always looking for is this picture or data out in the water? Well, there's reasons why it could be out in the water for real. Tides, water goes down, things like that. Okay, but I'm always skeptical when I start seeing data out in the middle of the ocean. Okay, and this goes right back that maybe it was a GPS error, the location error. The measurement itself might be fine, but where it's located is the challenge, right? So when I see something like this, I start going, oh, okay, I'm gonna have to fix that somehow. And this is where you can spend a lot of time moving these locations around and seeing, in this case, if we go to the site info and look at the latitude longitude, again, the first thing that I think of is, well, if I add a minus in one of these places, will it drop me into Mexico? Um, a place where I would more likely see this or think that this might be. So that is an exercise that I go through if I really want that data. If I know that maybe it is in my study area and it would help me, I will go through and look at and try to evaluate why this data point ended up in this location. Data archaeology is a bit what this is. This is also why it's really important for you to describe what you did, how you did it, why you did it, because all of us are just left with the data in the database. And unless you share with us through those research projects some of these nuances, we're left scratching our head with this particular data point. And unless we can describe it, we basically have to delete it out of the database at a certain point and not move forward with it. And that is a shame. We don't want to lose people's data. And so making sure that you are submitting good data allows us to make sure that we can use it in processes moving forward. The other thing here that I want to stress is that it's not just that thematic data that is really useful, right? If you go in, you can change some satellite measurements and data and actually turn on, like, the satellite view of this. Again, we're trusting that Microsoft has put us in the right place in the world. There's some assumptions there. But again, one of the things that that allows me to do is zoom in uh, on this location and see, again, are there green pixels? Are there things that match this? And right now, because this is out in the middle of black, I unfortunately would have to remove this from this data set because great photos, great information, but it's in the wrong place. And so ultimately, when we go to do the work of our science and start bringing in our NASA satellite data, uh, like any of these things, let's just get a chlorophyll A up there. Um, this is where that data is not going to align, and it's going to cause problems, and people are going to not be able to answer the question because you cannot geographically align these measurements like this. So that to me is one of is how I approach our data in the Globe database. And again, for me, one of the big opportunities here is that we have a lot of spatial data in the world. And here I went to one that I have really started to pick up and really like is called Earth Map. And this facilitates access and ways of getting at data. Again, this location piece is the link and really the key that we're after. But this is a food and agricultural organization piece. They've uploaded their own geometry of different countries. Again, before I actually use this, I want to know a little bit more about who came up with this geometry. Is it correct? How big of an area is this? But once you go in and select an area, again, one of the things that we were trying to build at the beginning of the globe is these layers right here. They didn't exist 30 years ago. Now they exist. So you can actually go out there and find all kinds of land cover maps out there to describe the world at different moments in time. And so this is another little key here is pay attention to the date when data layers were made. Uh, because you can line those up with your measurements. You can use those to inform your current measurements, even if they're not exactly at the same moment. We'll always have a time lag between data and our measurements, but we can actually start looking at things like, what was Africa like in 2016? Well, we now have access to these data layers. And so the key is to make sure that we're measuring the right locations using these maps like this. And importantly, if you find errors in the Globe database that you recognize and you want to have changed or altered or updated, let us know. Send a note to help at globe.gov and let us know what is happening with the variety of data as you are actually going through what is in this database. And so again, I just want to stress that visual looking at this data in the spatial location is a really good first step. Then there's ways within that GPS protocol in particular that talk about how to quantify some of these errors, or not really errors, but just measurement limitations that are there. So with that, like I said, there's a lot of things that you can dive into with this. Technology has changed. You can do it coding wise. You can do it in the way that I was showing today, just with a lot of ocular estimates and doing some comparisons that way. And so we really want to stress that it's important to be thinking about not only the measurements that you're making today and how you're making it and describing those so that they can be researched in the future, but also importantly, thinking about the ways that we made the measurements in the past and being aware of the complementariness of making a direct measurement of something, measuring it with your tape, as well as measuring it with some of the lasers that we can do today, where we don't actually have to touch some of those things. So again, we encourage everybody to push us forward with what we can do with our measurements, but recognize that it's an evolving piece. And so a measurement isn't just a measurement, it has a lot of history and detail to it.
Thank you so much, Peter, for this wonderful, wonderful talk. It has been awesome. You're such a great speaker. Um, we have time for maybe one question. If there, we haven't had any in the chat yet, but folks, please feel free to send in a question for Peter. He showed us some really great resources, not only Globe resources, but some complementary resources, which are so important. Um, so if we get a question here, I actually do have a question. Maybe
Yeah,
another one will
great.
come in. For folks that are looking at these complementary resources, how is it the best, or how would you recommend folks comparing them? Looking at them side by side,
Yeah,
rather than looking at them kind of statically in a way.
exactly. Oh, I love that question because one of the things that we have that was that at first I kind of thought like, oh, technology has changed so much. There's no way that we're doing the same thing that we were doing in 1995. But one of the things when you actually go through the land cover protocols, the first one is all about going out and making those measurements with the tape, figuring out what's there. That's that's where it all starts. But then activity number two is taking that data and actually making a map with it. That's
Mhm.
great. And so, that right there is exactly what we want to do. Because one of the things that that reveals is if your things are in the right location or not.
Mhm.
If trees should always kind of look green or be kind of, similar in that way. So the second land cover activity, the manual land cover mapping activity, is a perfect one for them to be
Mhm.
able to follow and do. And then I want to stress actually that the third activity that goes with that is accuracy assessment. And so this actually walks you through how to overlay your points with those maps that I was just showing you on Earth Map in particular. And so it has you, it all starts with one comparison. So you pick at a point on a map and you get their prediction of your location that you measured. That's the first place that you start. And you just make a table that shows here's my numbers, here's their numbers, and that's it. That's it. And then describe, are they the same? Well,
Mhm.
why might they be different? And that's it. It starts with one. And the nice thing is that's all also built right within the Globe Observer app. And so if you go through and do your ground photos, and then you do the next step of classifying what you see in those photos, again, just an estimate, not
Mhm.
as good as making measurements, with the tape, but it's a good starting point. You then have a label for your location. Say trees is what you come up with. That's when you go exactly to what I showed you with the Earth map, and you just go and point and at exactly that same latitude, longitude, and it will show you that value. Or within the Globe Observer, you can click the compare button, and it will take you and show you the MODIS prediction at that location as well. So we've now moved from actually having this all outside and having to go to many different websites. In fact, you actually have that MODIS map within the Globe Observer land cover tool. So it's
Perfect.
it's wonderful because 30 years ago we did not have these maps. That was a big purpose for the Globe program, was to actually be able to make a land cover map. Well, 30 years later, scientists like me and other people, including Dr. Russ Congleton, who started the land cover protocol for Globe, we've all created new ones. And so now it's all about evaluating what has been out there. And and so, it's in that way we've flipped around what we need to do. And
Hmm.
our job really is evaluating these maps. And the way that we do that is make sure that when we're doing our Globe Observer photos of any location, it really is anywhere on Earth. Because as you saw, we're moving from very large pixels, say 1 kilometer pixels of size of an area, we're getting down to 10 meters. And that's basically what do you see right in front of you. And so again, I want to encourage people that there's a lot of data out there. We don't have to create it at this point. We get to evaluate it. And so, when people ask, where should I go make an observation? Everywhere. Whatever catches your fancy, whatever drives you, and you think is important to share with the world, do that. For me, it's trees. I spend all my time going around and going, oh, wow, that tree is really neat. And so I then, do my observation and put it into context. But that's my personal motivation. And I want people to find theirs because when you're walking around your world, you are noticing things, you're questioning things, and it's amazing when you pull out this little framing device, how it helps you to actually notice, hey, there's no sun in the north direction. Oh my gosh, wow. I'd never really thought about that, and so, you know, part of this really is us not guiding people where to go as much as it is an opportunity for you to share with us what's important in your community. What are the features that you are proud of in your community? It could be buildings, it could be open spaces, because ultimately what we've found is the world will change over 30 years. We don't know exactly where, we don't know exactly how, but that's one of those things that going out and making these observations prepares us for these unknown events that are going to happen. We know that, but we just don't know where or when. And so, I really want to encourage people to own this Globe program and think about it as a memory of your experiences, a memory that you can pass on to other scientists, other students. And that's what I've been doing with the Globe Observer photos. I've got a lot in there that are treasure hunts. And there's some little finds in there that who knows? I don't expect anybody to find for several years, actually. So that is one of these things. When I look back over 30 years, what people like Dr. Russ Congleton have provided to us with with his vision and his work, I'm trying to emulate and do my part at this moment in time. So I really appreciate everybody coming and joining us, and keep up doing your observations however you are submitting them and making them. We're really excited about this 30-year program. I want to offer up as a Globe partner. My focus is on change over time using satellite imagery. So if you want to dive into your area a little bit more, let me know. Reach out to me, and you see my contact all over the Globe website. And I'm really looking forward to seeing how the world has changed in our Globe communities over the last 30 years.
Thanks so much, Peter. Just really, really appreciate your time today. And I was going to say, if folks have a problem finding your contact information, you can connect with us through the campaigns at nasaglobe.org. We're happy to connect you. And, just a quick thing, when you're going out and taking these photos, just like Peter said, the Globe Observer app will guide you into the directions that you need to take these photos, but just get out and start taking them, looking at observations, and whatever, as Peter said, suit your fancy. So thanks again for being with us today. today. Thank you all for joining us. This will be on the Globe website, but go and check out and start going out and taking measurements and looking at that data. All right, everyone, have a wonderful rest of your day, evening, and go out and take some measurements. So
Thanks,
thanks again,
Grace.
Peter.
Bye.
Bye.